Hello, everyone, and welcome to our third 9 weeks review of Chapter 9. The first set of directions says to simplify each radical. Another way to say that is to leave these in simplest radical form. And so what we're going to do whenever we simplify radicals is we're going to create our perfect squares list. We're looking for perfect square factors in order to simplify these radicals. So to create this list, you can easily do 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, and so on and so forth. For the third 9 weeks test, if you go up to 100, that should be totally fine. So whenever we simplify the square root of 98, remember that the process is you see where that falls in the list. That falls between 81 and 100. So as far as estimating the square root of 98 goes, it's going to be somewhere in between 9 and 10. But we want to put this in simplest radical form. So what this does is this shortens my list of the factors that I'm checking. And so I can break the square root of 98 down into the first one that's going to work. The greatest perfect square factor is going to be 49. What is the square root of 49? It's going to be 7. So this becomes 7 root 2. 7 root 2 is my final answer for the simplest radical form of the square root of 98. Number 2, what is the square root of 100? Well, you'll notice that that is actually in my list. So square root of 100 is a perfect square. What is the square root of 100? That is a perfect square. That is going to be 10. So that is going to be a 10 is my final answer. Number 3 says 12 divided by root 6. Root 6 is fully simplified, but remember that to be a fully simplified radical, this is a fraction and we cannot have a radical in the denominator. And so in order to get rid of the root 6 in the denominator, we're going to multiply it by itself. Why do we do that? Because it becomes root 36. What's the square root of 36? That's going to be 6 wholes. But if we do that in the denominator, in order to keep this algebraically the same, we have to do that in the numerator. So this becomes 12 root 6. And so 12 root 6 over 6, I can divide those whole numbers. What is 12 divided by 6? That is going to be 2. So my final answer is going to be 2 root 6. Number 4, this says root 12 plus root 3. Currently, those are not like radicals, so I cannot add those together. But I can simplify root 12. What is a perfect square factor of 12? I'm going to start here and go up the list. My first and my biggest perfect square factor is going to be root 4. And so I can break this root 12 down into root 4 times root 3. And then 5 root 3 is fully simplified. So what is the square root of 4? That's going to become 2 root 3 plus 5 root 3. Are those like radicals now? Yes, the root 3's match. So what is 2 plus 5? That is going to become 7 root 3. 7 root 3 is my final answer. So that's just reviewing radicals and radical operations in this top section. All right, the next section says solve for the missing side length. Leave in simplest radical form. So you can see this popping up again. Okay, so this is going to be Pythagorean theorem. I have 2 out of the 3 side lengths of a right triangle. So remember that is a squared plus b squared equals c squared, where c is always my hypotenuse. And so I'm going to plug this in. I'm going to say 6 squared plus 10 squared equals x squared. That is going to be 136 equals x squared. So x is going to be the square root of 136. So take the square root of both sides. That is a decimal, and so what we need to do is see, are there any perfect square factors that I can take out? So I'm going to go up this list again. My first perfect square factor is going to be, I can break that down into a root 4 times root 34 equals x. And so what is the square root of 4? Since that is perfect, that's in my list. That is going to give me 2 root 34. 2 root 34 is my final answer for x. So 2 root 34 is that answer in simplest radical form. All right, let's do this again. I'm going to plug this into a squared plus b squared equals c squared, where c is always, always, always my hypotenuse. So let's plug that in. That is going to be x squared plus 16 squared equals 20 squared. So I'm going to subtract 16 squared from both sides. 20 squared minus 16 squared is going to give me 144. And so x is going to be equal to the square root of 144, which is a perfect square. That is going to give me 12. Okay. I do want to make sure that that makes sense as an answer. If x is 12, is that less than the hypotenuse of 20? Yes, it is. Let's do that for number 4 real quick as well. 2 root 34, when you type that in, that is more than 6, and that's more than 10. So that does make sense as an answer as well. So let's do the same thing for number 6. A squared plus b squared is equal to c squared. Where's my hypotenuse? It's across from that right angle, so that has to be the 13. So that is going to be x squared plus 7 squared is equal to 13 squared. So we're going to subtract 7 squared from both sides to get x squared by itself. And I get x equals the square, or the x is equal to 120. X squared is equal to 120. And so what is x going to be equal to? Square root of 120. And so now we just want to put that into a perfect square factor. So I can rewrite square root of 120 as root 4 times root 30. So what is the square root of 4? That is going to break down to 2 root 30. So 2 root 30 is my final answer. And the next section is more Pythagorean theorem. But this one, instead of saying leave it in simplest radical form, says to round your answers to the nearest tenth. So this one is going to allow us to, if it is not a whole number, to use the decimal form. And so again, Pythagorean theorem, a squared plus b squared equals c squared. So that's going to be x squared plus 13 squared equals our hypotenuse, which is always our c. So that's going to be equals 14 squared. So x squared is going to be equal to 27. So x is going to be equal to the square root of 27, which breaks down to approximately, when you type that in, we know it's going to be more than 20 square root of 25, which is 5. So square root of 27 should be really close to 5. It's going to be about 5.2. It says to round to the nearest tenth, so that's about 5.2. All right, same thing on this problem. X squared plus 9 squared is going to be equal to 13 squared because 13 is the hypotenuse. So I'm going to type in 13 squared minus 9 squared. That is going to give me 88 for x squared. So what is x? X is going to be the square root of 88. Of course, when we type that in, we know that that is going to be really close to 81 is 9. So it's going to be a little bit more than 9. And so that's going to be about 9.4 when I round that to the nearest tenth. Does that make sense as an answer? Is 9.4 in fact less than 13? Yes, it is. My last answer, 5.2, was less than 14 for the hypotenuse. So that made sense as an answer as well. Okay, last one. X squared plus 9 squared equals 12 squared. And so I'm going to subtract, because that was my hypotenuse, so that went in for the c value. I'm going to subtract 9 squared from both sides. And when I do that, 12 squared minus 9 squared is going to be 63. So x squared equals 63. So x is equal to the square root of 63. What's the square root of 63? Well, it's going to be real close to 8. Because the square root of 64 is 8, so the square root of 63 is going to be about 7.9. About 7.9 when I round it. So notice the first section was Pythagorean theorem in simplest radical form. The second section is Pythagorean theorem rounded to the nearest tenth. We try to test y'all on both of those. You never know how that's going to appear on a standardized test. And so I do want y'all to see the difference in that process. So that is numbers 1 through 9.